Hi, I'm Anthony, and today I'm going to answer a question that my mom asked, how do magnets work? And, well, it really depends on what kind of magnet you're talking about, because you could be talking about a natural magnet, just like something that's magnetic normally, or you could be talking about an electromagnet. So we'll start with the easiest one first, an electromagnet. How does that work? All you need to make an electromagnet is a battery, some wire, and something to coil the wire around, like a nail. As you can see, when we attach the wire to both ends of the magnet, the current flowing through the wire creates a magnetic field, which then attracts any magnetic materials. So that's how electromagnets work, but how do natural magnets work? Things that like iron and nickel that are naturally magnetic. Well, you can start at the most fundamental level with fundamental particles like the electron and the quark. These fundamental particles have certain properties like spin and charge, but but they also have a property called a magnetic moment, which basically just means that they're tiny little magnets. And why are they tiny little magnets? Well, we don't actually know why. We just know that they are, and that is the basis of why things are magnetic at all. So then we can go even further up to atoms. With atoms, you have your positively charged nucleus with protons and neutrons. And then orbiting around on the outside, not orbiting, they don't really orbit, but it's kind of helpful to imagine it that way, are the electrons. Not very good at drawing these orbits, but you have your electrons orbiting on the outside. And it's useful to imagine these orbits as kind of so if you have the atom, it's this blue circle here. Well, not the nucleus as this blue circle here, and then you have these energy levels. It's kind of useful to imagine them as different little rings that the electrons can be in, but it's a lot more complicated than that. So these rings are called shells, and they can only have certain amounts of electrons in them. The bottom one can only have 2. The next one up can only have 6, I think. And these electrons are all magnetic because they all have magnetic moments. But as they're orbiting all around this atom, most of the time in a full shell, they will be going in different directions, which means that their magnetic fields created by their magnetic moments will cancel out. So atoms with full shells of electrons will not be magnetic. So we can see on the periodic table, things that are closer to the sides will have closer to full shells of electrons, and will be not very magnetic. But in the middle, you'll have things like iron and chromium and etc. that will be magnetic atoms. The thing is, though, chromium isn't magnetic. If you try to stick it to a magnet, it'll just fall off. So why does chromium have magnetic atoms, but chromium itself isn't magnetic? Well, it's because for something to be magnetic, all of the atoms' magnetic fields have to align. That's called ferromagnetism. If they're all aligned in the same direction, ferromagnetism. And if you know some root words, you'll know that ferro means iron. So, and iron is one of the most notoriously magnetic materials, which is where the name comes from. But then you can have things that are where the magnetic fields of the atoms are all directly opposing each other. That's called antiferromagnetism. That's a big mess. And then you can have ones where the magnetic fields are all willy-nilly all over the place, and that is called paramagnetism. That's probably hard to read. So, if the atoms in a material are aligned, then they'll be ferromagnetic and very magnetic, like things like iron and nickel and cobalt are ferromagnetic. In fact, there's only 4 elements that are ferromagnetic, being the 3 I mentioned before: iron, nickel, cobalt, and then gadolinium. And then you can have antiferromagnetic materials where the magnetic fields directly cancel each other out. And then you can have paramagnetic materials where the magnetic fields are all over the place. But even in materials that are ferromagnetic, you might have like a chunk of iron that isn't magnetic. And that's because of things called domains. So you can split up the material into a bunch of different domains. And in these different sections of this chunk of iron, the magnetic fields in this section might be pointing this direction, these ones might be pointing this direction, and these ones might be pointing this direction. They're all pointing different directions, basically. So nothing is aligned. And so it's not magnetic. But if you can expose it to a magnetic field, some of them will align with each other. And then eventually that'll give the push needed to make everything else magnetic, which then makes it magnetized. So that's why when you like rub a magnet on a nail that's not normally magnetic, it can become magnetic because you've aligned all the magnetic fields in the nail, and now it's magnetic. So that's how magnetism of naturally magnetic things work. you have to have a very specific series of things happen. It has to be, its electron shells have to be not very full, and the atoms' magnetic fields all have to be aligned, and then all of the different magnetic fields in the different areas of the material all have to be aligned together. So you can see why only certain materials are magnetic, because it's really hard to have all of those things aligned at once. So yeah, I hope that answers the question, and if anyone has any other questions, just leave them in the comments below, and hope you have a good day.